The corporate firewall used to be a physical boundary. If you protected the network perimeter, you protected the company. Today, that boundary is semantic. Employees across every department are using generative AI to summarize meeting notes, rewrite daily emails, and draft new reports. This is shadow AI, unsanctioned and unmonitored. The vulnerability happens the moment an employee copies raw text containing social security numbers, patient records, or proprietary project codes and pastes it directly into an external AI prompt. This productivity shortcut is actually an untraceable data exfiltration event. The sensitive data slips past traditional network defenses and lands permanently in a third-party cloud database. Asking users to manually identify and redact every sensitive string before they hit send creates a persistent risk of human error. The standard industry response to this problem is Cloud Data Loss Prevention, or Cloud DLP. It attempts to secure the data by routing the prompt through a proxy server for inspection. But to inspect that data, the unredacted information still has to leave the user's laptop and travel across the internet to a third-party vendor's server. Strict privacy frameworks like HIPAA and GDPR penalize the unnecessary transmission of data. Sending raw user information to another cloud just to check it creates a new attack surface and adds significant processing latency. True AI data security cannot rely on trusting another cloud provider's privacy policy. It requires pushing the security perimeter to the client-side device. This is where Privacy Scrubber introduces zero-trust data sanitization. Instead of sending data out for inspection, the entire sanitization engine runs in the local browser's volatile RAM. It intercepts the text before the user clicks send. The entire sanitization process happens in milliseconds, completely invisible to the user, without making a single back-end API call. Running natively, the named entity recognition engine scans the prompt and identifies multiple classes of sensitive data, from credit card numbers to internal project codes. By eliminating the exposure vector right at the keyboard, organizations secure their AI pipelines without slowing down their workforce. The system replaces sensitive data with safe semantic tags. These tokens are sent to the AI, completing its task without seeing actual human identities. Users paste the AI response back, and a temporary in-memory session map translates the tokens back into the original data. This session map is never saved to a hard drive. The moment the browser tab is closed, the map is destroyed. The result is a closed loop. The AI gets the context it needs, but the human identity is permanently stripped from the transaction. Security tools should rely on verifiable architecture, not promises hidden in privacy policies. We prove this zero-server architecture through the airplane mode standard. If you load the extension and then disconnect your internet, the data sanitization engine continues to function. You can open your browser's developer tools and see 0 packets transmitted while the data is cleaned. 0 network packets mean 0 server logs. The data never leaves your machine, eliminating third-party vendor risk. This empirical evidence upgrades your compliance posture from trust but verify to verify locally. Because execution happens locally, it satisfies strict technical controls required by SOC 2, HIPAA, and GDPR. IT administrators can seamlessly push the Chrome extension to all employee endpoints via mobile device management, enforcing data minimization policies in the background. With ZTDS active, every browser acts as an air-gapped fault. Enterprises can give their entire workforce the speed of generative AI, backed by the verified security of an offline server.